Alright, 6th graders, lesson 65, prime factorization, division by primes and factor trees. Remember, numbers can either be prime or composite. Prime numbers are going to be 2, 3, 5, 7, 11, 13, and so on. They can only have two factors, whereas composites are going to be 4, 6, 8, 9, 10, 12, and so on. They have more than two factors. So if we look at some of these numbers, look at 4, that would be 2. The factors of 4 are 2 and 2. The factors of 6 are 2 and 3. The prime factors of 8 are 2 and 2 and 2. And the prime factors of 9 are 3 times 3. So we're going to learn how to do that for larger numbers today. The first way to do it is a division by primes. You take 60 and we divide it by prime numbers. It might help to remember up here 2 and 3 and 5 and 7, 11 are prime numbers. I can divide 30 or 60 by 2, and that would be 30. I'm going to do another division problem on top of that. 30 divided by 2 would be 15. 15 I can divide by 3, and that will be 5. So now all of the numbers out here are all prime numbers. Therefore, I'm done. So the prime factorization of 60, we have to rewrite it in order from least to greatest. So I got 2 2's, a 3, and a 5. So the prime factorization of 60 would be 2, 2, 3, and 5. So this is using division to figure out prime numbers. The next way is using a factor, what we call tree. We write numbers under it. They don't have to be prime, so I'll show 2 that are not prime, 6 and 10. Again, some prime numbers that we might want to end up with are going to be these numbers up here. I know 6, now I can divide into 2 times 3 will equal 6. To get to 10, I can get 2 and 5. So now I have all prime numbers at the bottom of my factor tree. I like to circle them just to remind myself I've come to the end. I can't factor them anymore. So again, we rewrite them in order from least to greatest. And those are the prime factors of 60, and this is using what we call a factor tree. And most often, as a student, you will use a factor tree. Alright, let's look at example 1. Use a factor tree to find the prime factorization 60, but they want to use 4 and 15 as the first branches. Neither of those are prime. Again, I usually end up with 2, 3, 5, 7, or 11. I can't end up with other ones. 4 is going to be 2 and 2. Those are both prime. I don't want to do those anymore. And 15 is going to be 3 and 5. I can't do those anymore. So the prime numbers of 60 again are 2 times 2 times 3 times 5. Alright. Example 2 says use division by primes to find the prime factorization of 36. So they want us to divide. So again, usually 2, 3, 5, 7, and 11, but not always. You can have more. Sometimes 13 sneaks its way in there. So I can divide this by 3. I see that there. And I see a 12. Now I divide the 12. I can divide that by 3 and I'll get 4. And that's not prime, so I got to divide that again by 2 and I'll get 2. So now I've got all prime numbers out here. So the prime numbers of 36 are 2 and 2 and 3 and 3. That would be my answer. And here I've done prime factorization using division. That's it for today. You can get started on your lesson practice, 6th graders.